I want you to try like a quick visualization exercise with me. When you hear a phrase like the cloud, or when you mentally picture the AI revolution, what actually pops into your head right now?
I mean, for most people, it's probably something completely weightless, right?
Yeah, exactly.
Yeah.
You're probably visualizing like an endless stream of glowing digital code, or maybe sleek software interfaces, or just, I don't know, data packets floating through the ether.
And while the tech industry has spent the better part of 3 decades selling us that exact illusion, we've been completely conditioned to think of innovation as this invisible, frictionless force that just sort of lives in the air around us.
Right. But we are going to tear down that perception right out of the gate for today's analysis, because honestly, the reality of the artificial intelligence revolution is the farthest thing from weightless.
Oh, absolutely. The digital revolution is entirely bound by physical law.
Right. The future of AI is actually made of like thousands of tons of poured concrete, massive industrial plumbing systems, and these heavy-duty, highly localized power grids.
Yeah, we are looking at a massive global shift here. The boom in artificial intelligence is completely remapping physical real estate and, well, physical infrastructure.
And this is exactly why you, the listener, really need to understand the mechanics behind this shift. Because navigating the AI era, it's no longer just about figuring out which new chatbot writes the best marketing emails.
No, not at all. It is about understanding the hard physical bottlenecks of the technology itself.
Exactly. We're talking about raw electrical power generation, the actual physics of fiber optic networks, and the pure scarcity of physical square footage.
And those physical constraints, they are the ultimate filter right now.
Yeah, they will absolutely dictate which businesses actually survive the next decade of AI integration and, well, which ones fail simply because they literally cannot plug their systems into the wall.
Right. So to really see how these bottlenecks are reshaping the market, we're going to look closely at a recent highly strategic move by an investment manager called I Squared Capital.
Right, okay, let's get into the details of that deal.
So they recently closed a $225 million all-cash deal to acquire a portfolio of 10 data center facilities from a company called Cogent Fiber.
Let's put some dimensions on that footprint so we know exactly what we are dealing with. We are looking at facilities spread across 9 major U.S. metropolitan markets.
Yeah, we're talking about key regional hubs. Places like Chicago, Atlanta, Houston.
Right. And in total, these assets encompass about 259,000 square feet of space, which, if you think about it, is roughly 4.5 American football fields of just pure server capacity.
It's massive. And along with that space, they acquired 53 megawatts of secured power capacity.
Okay, let's pause on that. To put that 53 megawatts into perspective, for anyone who isn't, an electrical engineer, that is enough dedicated electricity to run somewhere in the neighborhood of 40 to 50,000 standard U.S. homes.
Wow, yeah.
And that's just for these 10 buildings.
Right, so that is a massive draw on the local utility grids. And honestly, having that power already secured, that's the real linchpin of this entire acquisition.
I have to be completely honest, though. I am looking at that $225 million price tag. And, well, in the context of the current AI arms race, it sounds like a rounding error.
I mean, I get why you'd say that.
Right, because we see headlines every single week about the major tech giants throwing tens of billions of dollars at new AI infrastructure. A $225 million acquisition feels a bit like someone buying a tiny rundown starter home just so they can claim they live in an obscenely expensive, highly desirable zip code.
You know, that starter home analogy actually captures the initial scale perfectly, but it misses the actual mechanics of infrastructure investing.
Oh, how so?
Well, I Squared Capital isn't looking at these 10 facilities as a finished product. They aren't just moving into the starter home and calling it a day.
Okay.
They are treating this $225 million acquisition as a foundational footprint. Alongside that initial purchase price, they have already committed an additional $1 billion.
Wait, $1 billion just for these 10 sites?
Exactly. $1 billion specifically allocated for upgrading, expanding, and scaling this exact portfolio.
Oh, okay, I see. So the starter home basically comes with $1 billion renovation budget to tear down all the walls and add like 3 news stories.
Yeah, it is a classic platform strategy. You see, in the heavy infrastructure space, buying one isolated, multi-billion-dollar mega facility carries enormous centralized risk.
That makes sense. all your eggs in one massive concrete basket.
Right. So instead, you acquire a distributed base and network of smaller interconnected assets, and then you systematically upgrade them to handle high-density computing.
Because the demand for compute capacity is just massively outstripping what the power grid can even supply right now.
Exactly. So securing a platform of existing, already plugged-in buildings gives them an immediate launch pad, while all their competitors are literally still sitting around waiting on construction permits.
Okay, that makes the underlying financial logic much clearer. They are buying the foundation rather than the finished mansion. But this brings up a bit of a geographic puzzle for me.
Okay, what's the puzzle?
Well,
Uh-huh.
we know what they bought, and we know the capital they are deploying. But why target these specific regional U.S. cities? Like, why acquire a facility in downtown Chicago or right outside Houston?
That's the real question.
Right. Because if raw power and physical space are the ultimate goals here, why not just go buy 10,000 acres of dirt-cheap land in the middle of a desert somewhere, build your own massive solar farm, and construct a brand new, colossal mega campus from scratch?
Well, the answer to that actually lies in how the AI boom itself is maturing right now. We are currently watching the entire industry pivot from the training phase of artificial intelligence into the inference phase.
Okay, those are two massive buzzwords in the industry right now. And the physical requirements for each of those phases are completely different.
Completely different.
Let's look at AI training first. So this is the brute force phase, right? This is when developers are actually building and refining these massive language models, feeding the software trillions of parameters so it can, learn how to recognize patterns, write code, or generate video.
Right. And that brute force process requires a staggering concentration of computer chips running continuously for months at a time.
I can't even imagine the power bill.
Oh, it's astronomical. The heat generation and the power draw are just off the charts. But because training an AI doesn't require any real-time interaction with human users, you absolutely can build those massive training data centers out in the middle of nowhere.
Oh, okay. So precisely where land and electricity are cheapest. The AI doesn't care if it's sitting in a cornfield in Iowa while it reads the entire internet.
Exactly. But inference is the exact opposite. Inference is the application phase. It is taking that fully trained model and actually deploying it in the real world to solve problems in real time.
So like the chatbot instantly answering your complex customer service question.
Right. Or the financial software analyzing a credit card swipe and detecting a fraudulent transaction before the cashier can even hand you your receipt.
Okay, so the defining metric for inference has to be latency then. The time it takes for a data packet to travel from a user's device to the AI server, be processed, and travel all the way back.
Yes. Latency is everything in inference.
It's almost like, okay, let me see if I can map this out with a real-world scenario.
Go for it.
Think about a really high-end culinary school. Training an AI is like sending a chef away to a highly isolated culinary academy up in the mountains for 4 solid years.
Okay, I'm with you.
They are entirely disconnected from any actual restaurant customers. They are just intensely learning every single recipe, mastering the knife skills, absorbing all the foundational knowledge.
And that isolation is actually a benefit during that phase, right? It allows for completely uninterrupted processing.
Right, but inference is taking that master chef out of the isolated academy and putting them inside a fast food truck right on your neighborhood street corner.
That's a great way to put it.
Because when you walk up to that food truck window and order a highly complex meal, you expect it handed to you in 30 seconds. You do not want the food truck to have to radio the culinary school 3 states away to figure out how to grill the burger.
No, of course not. And that captures the necessity of physical proximity beautifully. In the digital architecture of the internet, that food truck must be placed exactly where the density of customers is highest.
Because even though data traveling through fiber optic cables is incredibly fast, it is still constrained by the speed of light.
Right. Yes, the speed of light and the refraction of the glass inside the cables. So if a hospital in Atlanta needs an AI to analyze a live surgical video feed for anomalies, sending that massive video file to a centralized training server out in rural Oregon, and then waiting for the analysis to come back.
That introduces latency.
Exactly.
And I mean, in a surgical environment or like an autonomous driving environment, a delay of even 200 milliseconds is literally the difference between a successful maneuver and a total catastrophe.
Right. Lower latency demands local processing, and this shift toward distributed inference is the exact reason why these regional data centers, those facilities in places like Chicago, Atlanta, and Houston, have suddenly become highly sought after premium real estate.
So the AI has to live in the exact same zip code as the people and the businesses using it.
Yes, it really does.
Okay, but so if the overarching rule of the inference era is that AI must be local, why don't the massive tech companies just drop $1 billion and build their own brand new state-of-the-art inference data centers right in the heart of every major metropolitan city?
Well, that is where the grand digital ambitions of Silicon Valley violently collide with the physical realities of civic infrastructure.
Ah, we are back to the concrete and the heavy-duty grids.
We are. Building a new high-density data center in a major U.S. city right now is bordering on impossible.
Wait, really? Impossible.
Pretty much. Gautam Pandari, the co-founder of I Squared Capital, highlighted a critical framework for this. He noted that the long-term compounding value of a data center is dictated by a strict rule of three:
Okay, what's the rule of three?
location, power, and connectivity.
Let's pull that apart, starting with power. Because from everything you're saying, that seems to be the ultimate choke point.
It absolutely is. The local electrical grids in most major U.S. cities are completely tapped out. I mean, these aren't standard office buildings we're talking about here.
Right, they aren't just powering some fluorescent lights and coffee machines.
No, a modern AI data center draws an industrial amount of electricity. When a major tech company approaches a local utility provider in a dense urban area and asks for, say, 50 megawatts of new capacity,
The utility company probably just laughs at them.
basically, they often have to flat out say no. The transmission lines can't handle it, the local substations aren't built for it. And upgrading that civic infrastructure, that can take 5 to 10 years of regulatory approvals and construction.
Wow. And then add to that the scarcity of urban land itself and the incredibly hostile local permitting processes. I mean, nobody wants a massive windowless humming concrete box built next to their neighborhood, sucking down the local power supply.
Exactly. The supply of new data centers is artificially capped by these physical and regulatory bottlenecks. And this is happening right at the exact historical moment that the demand for AI inference capacity is going exponential.
Okay, so going back to the deal. I Squared Capital isn't just buying 10 concrete buildings.
No. They are buying guaranteed, grandfathered-in access to municipal power grids in markets where you simply cannot get a new electrical connection approved today.
That is brilliant, but honestly, it creates a rather terrifying scenario for anyone who isn't part of the trillion-dollar tech club.
Yeah, it really does.
Say you run like a mid-sized healthcare network or a regional logistics and shipping company. You look at the market and realize you desperately need to integrate AI inference to optimize your supply chains, or you will literally be out of business in 3 years.
Right. It's adapt or die.
But you don't have $1 billion to build your own data center.
Yeah.
And even if you did, the utility company wouldn't give you the power permits.
So how do regular enterprises survive this bottleneck?
Well, the market has engineered a highly practical bridge for these enterprises, and it's actually the core component of the Cogent Fiber acquisition we've been talking about.
Okay.
It's a model known as colocation space.
Ah, okay. I did notice that specific term in the breakdown of the deal. Out of the total square footage acquired, roughly 259,000 square feet was dedicated colocation space.
Yes.
Walk us through the actual mechanics of how colocation solves the enterprise problem. So, colocation operates on a shared infrastructure model. Instead of a logistics company trying to buy land, negotiate with utility monopolies, and build an industrial facility from scratch, they simply lease physical space inside a third-party data center.
Okay.
The enterprise purchases their own proprietary AI servers and their own specialized computing equipment, and they just physically install it inside the colocation facility.
You know, it sounds incredibly similar to the co-working space model that exploded a decade ago.
Yes.
But like engineered for heavy industrial machinery instead of freelance graphic designers.
The structural parallels are definitely there, yeah.
Because when you rent a desk at a premium co-working space, you bring your own laptop, your own proprietary data, and your own brain power.
Right.
But the building owner is the one responsible for keeping the lights on, providing the enterprise-grade Wi-Fi, paying the massive air conditioning bill, and keeping a security guard at the front desk.
Exactly. And in the realm of high-density AI computing, the air conditioning and the security are industrial-scale operations. It's not just a window unit.
I can imagine.
Traditional data centers use these massive air conditioning units to blow cold air through the server aisles. But modern AI processors run so intensely hot that air simply cannot absorb and carry away the thermal energy fast enough.
Wait, so what do they do? Do they have to move to, like, liquid cooling?
Yes, exactly. They have to physically plumb chilled liquid coolants directly into the server racks.
Oh, wow. Directly into the racks.
Yeah, running it in a closed loop right over the microchips to prevent them from literally melting themselves to the motherboard.
That is wild.
It is, and it requires specialized piping, leak detection systems, and massive water access. It's a huge infrastructural undertaking.
So colocation basically allows a mid-sized business to essentially rent premium, heavily fortified digital real estate. They get all the benefits of the massive electrical loads, the complex liquid cooling architecture, and the high bandwidth fiber connections, all without having to navigate impossible zoning laws or pour the concrete themselves.
Spot on. It totally democratizes access to the AI infrastructure layer. Because as AI capabilities become a mandatory operational requirement for every sector of the global economy.
Which they are, from finance to manufacturing to agriculture.
Exactly. The demand for this kind of flexible, rentable colocation infrastructure is just going to become insatiable.
Which means this shift from centralized training out in the middle of nowhere to distributed inference inside the cities is turning existing, heavily powered urban real estate into the most valuable asset class on the market.
Without a doubt. But, power constraints and the laws of physics aren't just an American phenomenon.
Oh, of course not. The infrastructure bottlenecks have to be entirely global.
They are. And to see how investors are positioning themselves for this on a global scale, we can look at another move by this exact same firm. Earlier in 2026, I Squared Capital agreed to acquire a majority stake in Ilea.
Right, Alea. They are one of the premier data center platforms operating down in Brazil, correct?
Yes, they are a massive carrier-neutral platform in the South American market because infrastructure investors are recognizing that the AI economy requires a comprehensive global physical stack.
It's a total paradigm shift.
Yeah.
I mean, the narrative used to be solely focused on which company was designing the fastest microchip or writing the most elegant software algorithm.
Right. It was all about the code.
Yeah.
But a microchip without a power source is really just an expensive piece of silicon.
Yeah, a very expensive paperweight.
Exactly. The investors who are controlling the physical supply chain of computation, they are emerging as the new kingmakers. You need the heavy electrical power generation. You need the subterranean fiber optic networks to transport the massive data sets.
You need the industrial liquid cooling systems.
Right. And you need that localized edge computing capacity to actually deliver low latency inference to the end user. That entire stack exists strictly in the physical world.
You know, there is a profound irony in all of this that I just keep coming back to.
Oh,
Well, for the last 20 to 30 years, the central promise of the internet was dematerialization.
oh, right.
We were constantly promised that everything was moving into the invisible cloud. We joyfully replaced heavy steel filing cabinets with digital folders. We swapped massive physical record stores for weightless streaming apps on our phones.
We really did.
The prevailing wisdom was that the future of human innovation was going to be entirely digital and completely untethered from the physical world. And yet, this ultimate digital revolution, the creation of artificial intelligence, turns out to be completely, utterly, and unavoidably dependent on old-school, heavy-duty physical infrastructure and massive real estate investments.
It really is the great paradox of the AI age. The smarter and more ethereal our software becomes, the heavier, hotter, and more power-hungry the hardware required to run it becomes.
Yeah.
And this acquisition we've been looking at, it's a perfect bellwether. It proves that the artificial intelligence boom is no longer just a software engineering story. It is a commercial real estate story. It is a localized energy grid story.
And fundamentally, it is a massive capital investment story.
Absolutely.
Let's synthesize the core mechanics of what we have covered in today's analysis, because understanding this physical supply chain really changes how you view the entire tech sector. First, the architecture of AI is fracturing into two distinct phases. While the brute force training of models can happen in massive, centralized, rural facilities,
The actual application of AI, the real-time inference, must move to regional, distributed centers to defeat the physics of latency.
Right. The culinary master chef must eventually move into the neighborhood food truck to serve the actual customers.
Love that analogy.
Second, because municipal power grids are pushed to their absolute limits and urban land is scarce, building new inference data centers in these regional hubs is hitting a bureaucratic and physical brick wall. That bottleneck transforms any existing, fully powered facility into a priceless strategic asset.
Because if a facility possesses the holy trinity of location, secured power capacity, and deep fiber connectivity, it basically controls the choke point of the new economy.
Exactly. And finally, for the vast majority of non-tech enterprises that need to run AI but cannot afford to build their own infrastructure, colocation space serves as the essential practical bridge. It provides the high-tech, liquid-cooled co-working space for servers that keeps the broader economy from being locked out of the AI era.
The competitive moat in the technology sector is just no longer just about who can write the largest software model. The real race now is about securing the physical infrastructure necessary to actually turn those models on and, keep them running without melting the grid.
Which brings me to a final thought for you to carry forward, and it completely disrupts how we think about value in the physical world. For the last century, we have valued prime real estate based on highly visible, human-centric aesthetics. We assign massive premiums to penthouses with sweeping skyline views or sprawling properties with pristine waterfront access.
Right, the traditional markers of luxury.
But if the ultimate limiting factor of human progress is no longer our ingenuity, and it isn't the software code itself, but rather our pure physical ability to generate electricity and cool down concrete buildings,
Then the entire paradigm of what makes a piece of land valuable is going to invert.
completely, we might very soon wake up to a future where the world's most valuable, highly contested, aggressively guarded real estate is no longer based on a beautiful ocean view. Instead, the most expensive plots of land on Earth might simply be the unremarkable, windowless lots sitting directly on top of high-capacity electrical substations and intersecting subterranean fiber optic cables.
Wow. Yeah, the new definition of prime real estate is wherever the artificial intelligence can physically plug in.
The physical grid is the new gold mine. Thank you for joining us for today's analysis. We hope the next time you use a seemingly weightless instant AI tool to generate an image or answer a question, you take a moment to look past the glowing screen. Think about the poured concrete, the rushing water, and the humming copper wire working overtime right in your own city to make that digital magic happen.